Hello students, let's continue with Quadrilaterals chapter, part 10. Same section, 7.4 and 7.5 examples. We are continuing with the same section. In the last video, we practiced some examples through which we understood diagonals bisect each other in a parallelogram theorem. Hope all of you have understood and learned this theorem even better than what we have learned earlier. We'll practice some more examples in this video. So example number 4, two parallel lines L and M are intersected by transversal P. See the diagram. So there are two pink lines L and M and one transversal P. So P is intersecting both the lines. The question is, show that the quadrilateral formed by the bisectors of interior angles is a rectangle. So AB you can see is a bisector of angle PAC, correct? So AB is a bisector of angle PAC and similarly CD, BC, AD. Each one are bisector of the angles formed between the parallel lines and the transversal. So we have to show these four sides when these four bisectors they intersect at two places, they form a rectangle. This is what we have to show. So let us see in the next page how to do it. Before that, you can see the colors what is given is not in your textbook, that you know very well. It will be black and white. Similarly, the question papers, exam, everywhere it will be black and white. This color is given only for better understanding. So when you do any practical example, do it only either in a black ink or in a blue ink. Don't do in multiple colors, so that you are able to understand even without this color concepts. Let's go to the next page for solution. So angle PAC equal to angle RCA, alternate interior angles theorem. So now you will be able to recollect what you have discussed in lines and angles chapter. PAC is one alternate angle, one interior angle. The alternate of that is ACR or RCA. So both are equal. Therefore, half of PAC equal to half of RCA. Why we are seeing half, we will see in the next step, you will be able to understand. Now I will put the pink color also for you to understand the angles. Yes, these two angles are equal. Therefore, BAC angle and DCA are equal. So the reason is half of PAC is nothing but BAC, because BA is a bisector of PAC. Similarly, half of RCA is nothing but DCA, because DCA is CD is the bisector of DCA. Now I am putting that blue color also angle so that you understand better. Therefore, AB is parallel to CD. So earlier we saw lines L and M are parallel, L and M are parallel. Therefore, the interior angles are equal. Now it is converse. Since the interior angles formed between two lines AB and CD by the transversal AC or P, whatever, they both are equal. Because both are equal, converse of that theorem, that alternate interior angles are equal, that means these two are parallel. Similarly, we can prove BC parallel to AD considering angle QCA and angle SAC. So I will just show SAC where it is, SAC. Similarly, at the bottom if you see QCA, these two form a pair of alternate interior angles. Both are equal. If you prove the theorem, if you do further steps based on that, you will know that BC is parallel to AD. Therefore, ABCD is a parallelogram. Each pair of opposite sides is parallel. So that is what is the basic definition of a parallelogram. It is not a theorem, but it is a basic definition of the parallelogram is that each pair of opposite sides should be equal. Now we have proved this is a parallelogram, but we have to go to the next step, that is it is a rectangle. Now think about it, don't go forward, pause the video and note down your answer. What should be the next step? And then compare with what I am going to tell to see whether what you have thought is correct. Let's move forward. Now angle PAC plus angle SAC equal to 180 degrees. That is, they are in the straight line. PAC plus SAC, it is in the straight line PS or L. So it is 180 degrees. Again, half of PAC plus half of SAC equal to 90 degrees. Same like what we saw in the previous page, why we are seeing half. Therefore, half of PAC is nothing but BAC and half of SAC is nothing but DAC. You can make out because both are angle bisectors. AB and CD are angle bisectors. Therefore, half of each of the angle equal to 90 degrees, or angle BAD, that is BAC. You see, BAC plus BAC forms the angle BAD. So, adjacent angles form together the main angle, that is BAD. See the angle symbol also in BAD I have given in green. So, therefore, one angle is a right angle. Therefore, ABCD is a rectangle, a parallelogram in which one angle is a right angle. And I am putting thus proved quadrilateral ABCD is a rectangle. It is a very simple proof. First we proved that the bisectors form a parallelogram. Then we checked one angle and then we are able to prove that it is a right angle. From that we are able to say the quadrilateral formed is ABCD is a rectangle. So this is the answer. So easy to follow. Pause the video, note down these steps and then go to the next page. So in this video, we practiced some examples and understood some of the concepts. You can see the word I have changed here. This is not a theorem. Each pair of opposite sides is parallel in a parallelogram, because the basic property of a parallelogram is a quadrilateral where each pair of opposite sides is parallel. That is why it is not a theorem. It is neither an axiom also, but it is a concept. So I changed the word instead of theorem. In this video, we have learnt a concept. Practice some more examples to understand the theorems learnt in that will be the next video. Again, going back to the previous paragraph, if you don't know why it is a concept, you can check the theorems you have noted down in this chapter starting from 7.1 to 7.8, right? 7.1 to 7.8 we have learned so far. So you can just see that each pair of opposite sides is parallel in a parallelogram is not a theorem. This is what, even if you see the types of quadrilateral and types of parallelogram, I have written in red. Each pair of opposite sides are parallel. Reason is, it is a property, basic property of a parallelogram. It is a basic definition of a parallelogram. Now we have two questions in this page. These are from textbook. You can pause the video, note down and then go to the next page. There are three questions in this page. Pause the video, note down, and then after you understood this video thoroughly, answer all the questions. That's all for this video. Thank you.